Hello everyone, myself Sushmita. I'm currently pursuing my BE degree in Sri Venkateswara College of Engineering in CNC department. In this video, I'm going to explain a small topic on joint probability and Markov chain, which is related to mathematics. Here is the first topic, that is what is joint probability. Probability is a branch of mathematics which deals with the occurrence of a random event. In simple words, it is like a likelihood of a certain event, a statistical measure that calculates the likelihood of two events occurring together and at the same point in time is called a joint probability. Here is an example, that is let A and B be the two events. Joint probability is the probability of event B occurring at the same time that event A occurs. The formula to find the joint probability, it is notation to represent the joint probability can be a few different forms, that is P is equals to A integration of B, where A comma B are two events. P of A and B comma P of AB is the joint probability of A and B. The symbol between the A and B is in a joint probability is called as an intersection. The probability of event A and event B happening is the same thing as the point where A and B intersect. Hence, the joint probability is also called the intersection of two or more events. We can represent this relation using a Venn diagram. This is called as a Venn diagram. Next topic is joint probability distribution. Let A and B be the random variables which are defined on the probability space. The probability distribution that gives the probability that each A, comma B falls in any particular range or discrete set of values sacrificed for the variable is defined as the joint probability distribution. In the case of only two random variables, this is called as a bivariate distribution. Otherwise, it is a multivariate distribution. The joint probability distribution can be expressed in different ways based on the nature of the variable. In case of discrete variables, we can represent a joint probability mass function. For continuous variables, it can be represented as a joint cumulative distribution function or in terms of a joint probability density function. Here are the joint probability examples. Let us see some examples of how to find the joint probability with solutions. The first is find the probability that the number 3 will occur twice when two dice are rolled at the same time. So for dice, the number of possible outcomes is 6, that is 1, 2, 3, 4, 5, 6. Let A be the event of occurring 3 on first die and B be the event of occurring 3 on second die. So we are going to throw the die two times. So in let A be the event occurring at 3 on first die. Then second die we are taking it as B. Both the dice have 6 possible outcomes. The probability of 3 occurring on each die is 1. So for dice it has 6 faces. We are going to get 3. So 1 by 6. Then P of B is also 1 by 6. Then A comma B, A intersection of B is equals to 1 by 6 into 1 by 6. That is 1 by 36. Next is joint probability table. The joint probability distribution represents a probability distribution for two or more random variables. Instead of events being labeled A and B, the condition is used to use X and Y are given below. The main purpose of this is to look for a relationship between two variables. For examples, the below table shows some probabilities for events X and Y happening at the same time. Then next topic is Markov chain. What is Markov chain? The Markov chain is a stochastic model that uses mathematics to predict the probability of a sequence of events occurring based on the most recent event. The common example for Markov chain in action is the way Google predicts the next word in your sentence based on the previous entry within Gmail. Then the Markov chain is a stochastic model created by the Andrew Markov that outlines the probability associated with the sequence of events occurring based on the state in previous event. It is very common and easy to understand model that's frequently used in industries that deals with sequential data such as finance. The main goal of the Markov chain is to identify the probability of transitioning from one state to another. One of the primary appeals to Markov chain is that the further state of a stochastic variable is only dependent on its present state. An informal definition for a stochastic variable is described as a variable whose values depends on the outcome of random variables. Then, what are the main characteristics of Markov chain? Is the main characteristics of Markov chain is the property of memorylessness. The predictions associated with the Markov chain are conditional on its current state and are independent of past and further states. The memorylessness attribute is both a blessing and a curse to the Markov chain model in applications. Imagine a scenario in which you wish to predict words or sentence based on the previously entered text. Similar to how Google does for Gmail, the benefits of using the Markov chain to do is that is that the newly generated the benefits of using the Markov process to do this is that the newly generated predictions would not be dependent on something a whole paragraphs ago. However, the downside is that you won't be able to predict text that's based on the context from the previous state of the model. This is a common problem in natural language processing and an issue any models face. How to create a Markov chain model? A Markov chain model is dependent on two key pieces of information, the transition matrix and the initial state vector. Firstly, what is the transition matrix? It is denoted as P. This n into n matrix represents the probability distribution of the state's transitions. The sum of probabilities in each row of the matrix will be 1, implying that this is the stochastic matrix. Next, what is initial state vector? Denoted as S, this n into 1 vector represents the probability distribution of starting each of the n possible states. Every element in the vector represents the probability of beginning at that state. Next is what is an example for Markov chain? The common applications of Markov chain in data science in text prediction. It is an area of NLP that is commonly used in the tech industry by companies like Google, LinkedIn, and Instagram. When you are writing emails, Google predicts and suggests words or phrases to autocomplete your email. And when you receive messages on Instagram or LinkedIn, those apps suggest potential replies. These are the applications of a Markov chain we will explore. That said, the types of models these large scale companies use in production for these features are more complicated. Thank you. Thank you for watching the video.